Hello friends, hope you're all doing good. So welcome to Nauruza's CSC tutorial. On my last lecture, I had discussed greatest elements, least elements, upper bound, lower bound, supremum, infimum, maximal element, minimal element. Now, I'm going to share some of the examples on those topics. So starting with the first example. So this is the question. Let D40 be the set of all positive divisors of 40. Find whether D40 is a POset with respect to the relation rho, where A rho B means A divides B. Draw the hash diagram of the POset D40 and rho. Find the maximal, minimal element of D40. Find the greatest, least, and supremum and infimum of the subset A is equal to 4, 8, 10. Find whether the set A is bounded. Is 5 a lower bound of A? So let's start with the solution. So starting with the first question to solve, and that is whether D40 is a POset with respect to the relation divisibility or not. Here, D40 consists of these elements, like all the divisors of 40. So if we write the relation set of D40, and that will consist of these elements, like 1 will divide 2, 1 will divide 1 itself first, then 1 will divide 2, 1 will divide 4, 1 will divide 8, 1 will divide 10, 1 will divide 20, 1 will divide 40. Then 2 will divide 2, 2 will divide 4, 2 will divide 8, 2 will divide 10, 2 will divide 20, 2 will divide 40. Then 4 will divide 8, 4 will divide 20, 4 will divide 40, 5 will divide 10, 20 and 40, 8 will divide 40, 10 will divide 20, 10 will divide 40, 20 will divide 40. So this is the relation set of D40. So this is the POset with respect to the relation divisibility cause it is reflexive, cause here this relation set is consist of 1 1 2 2, or the element will has relation with itself, like 1 will divide 1, 2 will divide 2, and so on, 4 will divide 4. So this is the reflexive, the property has been reserved, so this is reflexive. And the relation set is antisymmetric also. Here 1 will divide 2, but 2 will never divide, or 2 will can't divide 1. So this is antisymmetric, and the relation set is also transitive, because if we see 1 will divide 2, 2 will divide 4, and 1 will also divide 4. So this is the transitive property, so there it has been reserved. So clearly it's a POset. The next question is to draw the hash diagram of D40. So clearly this is the hash diagram of D40. D40 consists of these, like the divisors of 40 consist of, so D40 will consist of this set. And if we draw the hash diagram of the given POset, and that is this, 1 will divide 2, 1 will divide 5, 2 will divide 4, then 5 will divide 10, 4 and 10 are on the same level, and they both divide 20. So 4 to 20 and 10 to 20, there will be 2 edges. Then the next element is 8, 4 will divide 8, then 10 will divide 20, and both are on the same level, 8 and 20, and they both will divide 40. So this is the hash diagram. So clearly the minimal element of this hash diagram is 1, cause no other element has been preceded 1, so 1 is the minimal element here. And the maximal element is 40, cause 40, no other element has not succeeded 40, so 40 is the maximal element here. Now greatest and least element. We have to find the greatest element of this subset and as well as the least element of the subset. So A has no greatest or least element, cause we can observe here that there is no any element we can divide by all other elements of A. So this subset has not any greatest element as well as least element, cause also we can observe that there is not any element present here by which we can divide all other elements. So A has not consist of any greatest or least element. Now supremum and infimum of A. Supremum of A is 40 cause A consists of these elements and the divisor of 40 consists of 1, 2, 4, 8, 10, 20 and 40. So the supremum of A is 40 cause only the subset 4, 8, 10, like for any element of A, we can divide 40. 40 will divide by 4, 40 will be divided by 8, 40 will be divided by 10 also. So the supremum of A is 40 and the infimum of A is 1 and 2 cause by 1 we can divide 4, by 1 we can divide 8, by 1 we can divide 10, and also for 2 we can divide 2, 4 by 2 we can divide 8 by 2, we can divide 10 by 2. So infimum of A is 1 and 2, and as 1 row 2, so infimum of A is equal to 2. Now the upper bound and lower bound. 40 will succeed every element of A and 2 will precede every element of A. So that is why the upper bound of A is 40 and lower bound of A is 2. So the set is bounded. And the number 6 question was, is 5 a lower bound of 40 or not? So clearly no, 5 is not a lower bound of A.